This lesson is going to be about plate tectonics, and plate tectonics kind of starts with this German guy named Alfred Wegener, and he looked at a map of the Earth and he noticed that a lot of the continents looked like they fit together. And if you look at a map, you can probably see that too. And he decided, he found some evidence that showed that the continents were once together. So he found some fossil evidence, he looked at the geology or the rocks, he looked at the climate, and he found that they had similar features. But the thing was, he could not explain how the continents moved apart, and so people kind of just laughed him off. But now we've done some more research and we've found a theory about how those plates are moving. And before we get to that theory, we need to know the layers of the Earth because we're going to be talking specifically about two of those layers of the Earth. And so here's kind of a sloppy drawing of the layers. And so the first layer here we have is the inner core. That's the very middle of the Earth. Then we have the outer core. So that makes sense, right? So outer core. Then we have our mantle. And this is one of the ones that we're going to be talking about today. This is the biggest of the layers, the mantle. And then on the outside, we have the crust, just like on a crust of bread. And the crust is the part that we live on. So for our lesson today, we're going to be focusing on the mantle and the crust. Those are the two layers that we're going to be looking at. So to look at the mantle and the crust, I've made a little close-up drawing of those two parts. And so here we see some of those words that we were just talking about. So here I see mantle, right? I see that word. And here I see crust. I see it twice. So I see that we have continental crust and we have oceanic crust. And it makes sense that the oceanic crust is the crust that's underneath the ocean. And we call the ocean and the water on the earth, we call that the hydrosphere. And so here we have oceanic crust underneath the ocean. It's like the ocean floor. We also have continental crust, which is where we live. So we have two types of crust. I also see some different words on here. So I see the word lithosphere right here. So lithosphere. And the lithosphere, I see that it incorporates, or it takes up the crust and this very top part of the mantle. And the top part of the mantle is really rigid. It's very hard. And so we have the lithosphere is the top of the mantle. And it is the crust. And so it's the top of the mantle and it is the crust, both the oceanic crust and the continental crust. And so here's our crust here. And so when we put those two together, we make up our plates, the plates that are a part of plate tectonics. So the lithosphere is our plates. And our plates are floating on top of what we call the asthenosphere. And the asthenosphere is also a part of the mantle. And the asthenosphere is basically, it's magma. And if you've heard of magma, you've probably heard of it when we talk about volcanoes. So when a volcano erupts, the lava shoots out the top. And when lava is inside the earth, we call it magma. And so the plates are basically floating on top of this magma. So there's a plate, and then we have our magma here, and they're kind of floating on top of it. So in this sloppy drawing of an Earth, I'm just going to show, we've seen pictures like this, and these are not accurate, but the Earth is completely made up of plates. So all of the continents and all of the oceans are floating on these plates. And the places where the plates meet up are called plate boundaries. And we're going to talk about the different types of plate boundaries. One type of plate boundary is called a divergent boundary. And a divergent boundary is a place where the plates are moving apart. The plates are moving apart from each other. So they're moving away from each other. If you've seen that movie or read the book Divergent, I'm not going to give any spoilers, but basically the character in there moves away or separates from the group. And that's what divergent boundaries do. They move away. And so we have some different types of divergent boundaries. So if we have two continental plates that are moving apart from each other, so a continental and a continental, what we get is we get something called a rift valley, which it's basically a ditch. Like it's pulling the continents apart and it's leaving space for that magma from the asthenosphere to come up and make new Earth. Another type of divergent boundary happens in the ocean, and we call this seafloor spreading. And it's kind of the same thing. So basically what happens is the oceanic plates move apart. So an oceanic and an oceanic move apart from each other. They diverge. And that leaves space for magma from the asthenosphere to come up and form new earth and new rock. And we see that when that hot magma hits that cold ocean, it makes the new rock. Another type of boundary is called a transform boundary. Transform boundary. And this is a place where the plates are sliding past each other. And we see transform boundaries in the United States and in tons of different countries. And so here's an example of a transform boundary, and we see two plates that are sliding past each other. And when we have this happening, so when we see plates sliding past each other, we get earthquakes. And so in California, if you're from California, if you've heard of earthquakes in California, we see that the Pacific plate is sliding past the North American plate. And I noticed that the arrows are pointing in the same direction, which means that one of the plates must be moving faster than the other plate. Because right here at the San Andreas Fault, we get a lot of earthquakes where those plates are moving past each other. When we talked about divergent boundaries, we talked about the fact that we're making new Earth. Magma's coming up from the asthenosphere, and it's making new Earth. And so we know that the Earth is the same size, and so we must know that that rock is going somewhere, right? The old rock. Because if not, the Earth would be getting bigger and bigger and bigger, and it's not getting bigger. This is where our last type of plate boundary comes in. So the last type of plate boundary we have is a convergent boundary. And a convergent boundary is the opposite of a divergent boundary. So for a convergent boundary, the plates are moving together, moving toward each other. They're moving together, they're colliding, they're converging together. There are a couple of ways that our plates can converge. One of the ways we have is if we have a continental plate and a continental plate coming together, we see that they're probably forming a lot of pressure. And what we get in that is a mountain. And so the rocks are colliding and they're forming a mountain. And this is what happened a long time ago when India collided with Asia, is it formed the Himalayan mountains. Another place that we see convergent boundaries is if we have an oceanic plate colliding with a continental plate, what we get is something called subduction. So the oceanic plate collides, and the oceanic plate goes underneath the continental plate. And the reason that it goes underneath the continental plate is because of its density. And to do this, we need to know what density is. And so when we think about density, we want to think about how tightly packed are the atoms. And the equation for density is density equals mass divided by volume. And so we're thinking about how much mass is in each volume. So how tightly packed is it? And the reason the oceanic plate goes underneath the continental plate is because it's more tightly packed. It's more dense than the continental plate. And when it goes down below the continental plate, what happens is it turns back into magma. It melts again and becomes magma. The question we have left to answer, though, is how are the plates moving? Just like Alfred Wegener was wondering how these plates are moving, what we've come up with now as scientists is this idea of convection currents. And convection is a form of heat transfer, so how heat can move through something. And it takes us back to density. So if we have atoms that are cooler, they are closer together and they are more dense. So the atoms in the crust are closer together and they are more dense. As atoms get warmer, they move further apart and become less dense. So for example, the magma here would be less dense. So as our plates are being pushed around and colliding and converging, they are more dense, so they are pushed down and become magma. The magma is less dense, so it's pushed up and it forms new rock. And this forms these currents that basically float the plates around the Earth. Pretty cool.